We're going to go over some basic grouping symbols. We're also going to go over the definition of exponent. We're also going to look how we can type these into Desmos to get the solutions. So the first grouping symbol we'll talk about is absolute value. And when we see a number inside the absolute value symbols, which is those straight lines up and down, we know that we want that number or that expression's distance from 0. So we're going to say a number's distance from 0. And you'll probably hear people say all the time, oh, it's always positive. Technically, it's always non-negative because it can also be 0. So we'll put always positive or 0. It's a number's distance from 0. We always talk about distance in a positive movement. So if I move on the number line 6 units, it doesn't matter if those 6 units are to the negative or to positive, I still have moved 6 away. So for instance, the absolute value of 1 is 6, and the absolute value of example 1 is 6, because the absolute value of 6 is 6, and that's also the absolute value of negative 6. If you want to know where to find the absolute value symbol in Desmos, you're going to click on the keyboard button, and you'll see it's right here, and then you can just type it in, and then it'll give you the absolute value. 0's absolute value is 0 because you don't move away from 0 at all, so it doesn't have any distance from 0. If remember, we treat the absolute value like any grouping symbol, so we evaluate what's inside. So 8 minus 3 is 5, and then we find the absolute value. Same thing here. 7 minus 15 is negative 8, and then we find the absolute value, which is 8. Now we're going to talk about exponents. Exponents are those little numbers. People will say, oh, little number. That little number. So that little number can turn numbers big really, really quickly. So for instance, a to the b means to multiply a. So when we're going to multiply a, and we're going to multiply it b times. So for instance, if we have 4 to the 5th, that means to multiply 4 times 4 times 4 times 4 times 4, which makes 1024. All right, so exponents make a number big really quickly. It also can make a number small really quickly, but that we'll talk about that another time. There's exponent buttons in Desmos. Again, you're going to hit the keyboard symbol. And here's the 2. You can either use that a squared if you want to square a number. So example 2 here, we did negative 6 squared. Notice that's a positive 36 because a negative times a negative is positive. Notice I put it in parentheses whenever you want to square a negative or put a negative to any power. We're going to want to put that in parentheses to make sure we get the right answer. If we want any exponent, notice that a to the b, that's how I did 6 to the 3rd here. So 6 to the 3rd, so I typed in that ab and I filled it in. And you get 216. 7 to the 4th. What I would do for these 3 problems, I would open up Desmos and make sure you can get those typed in the same way. So if I did 7 to the 4th, I would hit that AB button, put the 7 in the A section, 4 into the other one, into the box. So what happens is you should get 2 boxes. Put the 7 in here, put the 4 in there. And then when we do that, we get 2,401. 5 to the 3rd, 5 times 5 is 25, that's another 5. 125. Again, type that in Desmos, make sure you can get the same answer. And then example 5, that'd be negative 4 to the 5th. Negative 4 times negative 4 times negative 4 times negative 4 times negative 4. We know positive 4 to the 5th is 1024. And then if we have negative 4 to the 5th, we'll have a negative times a negative, which is positive, times another negative, which is negative, times another negative, which makes it positive again, and then times another negative, which makes it negative. So negative 1024. Again, type in Decimus, make sure you can get the same solution. We're going to talk about two different types of roots. We're going to talk about square roots, and we're going to talk about cube roots. Cube roots and square roots are the inverses of squaring a number and cubing a number. So let's talk about a square root. So if a squared equals b, then the square root of b equals a. So for instance, 5 squared equals 25. And so the square root of 25 is 5. We'll call it its positive root. The square root of 25 is also negative 5, because negative 5 squared is still a positive 25. Whenever we square a number, we always get a positive number. Therefore, if I want to do the square root of a negative, it's not a real number. Okay? That cannot be a real number. Because the square root of negative 25, you can't square a number to get a negative. Because a negative times a negative is a positive, and a positive times a positive is a positive. So there'll be a time in Algebra 2 when you are going to talk about negative square roots, and they're going to be imaginary numbers. And you're going to do lots of math with it, and it's a huge section of mathematics talking about negative numbers. I don't know if you guys can hear my cat running back and forth like an idiot right now, but she is. Okay, so she's still running. All right, to find the square root in the Decimus calculator, we're going to hit the keyboard button, and then right there is my square root. Type it in and put the number in. So for instance, the square root of 36 is 6. 6 times 6 is 36. The square root of 16. 4 times 4 is 16, so that's the square root. You type in the square root of, almost said 1,000, but that's 10,000. And that's going to be 100, because 100 squared is 10,000. Now, 36, 16, and 10,000 are called perfect squares, because when I find their square root, I get a whole number. If I find the square root of a number that is not a perfect square, it's actually going to be irrational number, meaning a number that goes on, a decimal that goes on forever. So, square root of 45, I type that into decimals, and I get 6.7 blah, 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 blah. We'll go one decimal. We'll call it 6.7. If I type in the square root of 1,342, and you should type it in as well, you get 36.6, something, 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 right? And we're going to talk about simplifying roots later this year, where if it's not a whole number solution, how can we simplify the radical so to a non-decimal answer, if that makes sense. It will when we talk about it. Cube roots. So just like a square root is the inverse of squaring a number, a cube root is the inverse of cubing a number. So if a cubed equals b, then the cube root of b equals a. So for instance, 5 cubed, we talked about it earlier in the notes, is 125. So the cube root of 125 is 5. Here's another interesting fact. Negative 5 cubed, a negative times a negative times a negative is a negative, is negative 125. Whoops, I'm giving away the ending. Hold on. Is negative 125. So the cube root of negative 125 is a real number. It's negative 5. So when you find the root of a cube root, it can be positive and it can be negative. Your solution is going to match the question. So for instance, the cube root of 125 is a positive 5, but the cube root of a negative 125 is a negative 5. We can find the cube root in the Desmos calculator. We hit the keyboard button. We're going to select functions, go to miscellaneous, and it's right here. And it's used for many different types of roots. So you can do fourth roots, you can do fifth roots, you can do sixth roots. And eventually, as an algebra 2, you'll do that. But we're going to stick to cube roots for now. So the cube root of 27 is 3. 3 to the third is 27. And the cube root of negative 27 is a negative 3. I would type these 3 questions into the calculator, making sure you know how to do it. The cube root of 64, 4 cubed is 64. And then 4 and 5, those don't have whole number solutions. So again, we're going to round. Again, we will talk about simplifying them. So if you type in the cube root of 234, when you type in Desmos, you would type in the calculator symbol, the functions button, and then that nth root. And when you get it, you would fill it in like this. You'd put a 3 in here. I don't know if you can see that. Let me try that again. You would put the 3 in there, and then in this place you put 234, and it would give you 6.2. And the cube root of negative 131, we know it's going to be negative. It's, oh good Lord, does it say negative 5.1? I can't read my own paper. So put in Desmos, see if it is. All right, so again, absolute values, a number distance from 0. Exponent tells you how many times to multiply a number. Square root is inverse of squaring a number, and cube root is inverse of cubing a number.